Now for part 2 of the video, finding the factor of dilation or scale factor. Again, these two terms may be interchangeable. You might get factor of dilation, or you might also get the scale factor. So the first step is to choose one vertex here from the original figure and the same vertex here from the dilated figure. So you might see this on a picture, or you might also be given these coordinates. So you want to choose one set of coordinates. Make sure that set of coordinates belong to the same vertice on your shape. So let me here give you t to be 2, 4, t v 5, 6, and s to be 3, 1. Now my dilated figure, let's say, is here, and these are the coordinates. Well, t prime for dilated figure, v prime for the other one. Let's see, what will be this here, and then my s prime will be this and this. So another question is, what is the dilator factor of this original shape being dilated into this shape? So here's a question you want to make. Again, you can choose one set of vertices, which will be maybe t and t prime. Remember, they have to be the same vertice from each dilated figure. So if you choose t, your other one will be t prime. You can choose b, your other one will be b prime. Or you can choose s, the other one will be s prime. And you have to compare these two. So you can either compare those two, you can either compare those two, or you can either compare those two. Or you can compare all of them. It'll be better if you compare all of them, just to be sure. Now, let me compare the first two set of vertices. Alright, so I'm going to be comparing t, 2, 4, with t prime, which is 6, 12. I want to find my factor of dilation. So here's the question you want to make to yourself. What do I have to multiply to 2 to get 6? And what do I have to multiply to 4 to get 12? Well, 2 times what equals 6? 2 times what equals 6? I have 2 times what equals 6? Well, by 3, right? 3. That 3 represents your factor of dilation, your scale factor. That's it. That is how you find the scale factor or factor of dilation. Again, I told you can compare either one, so you should get the same factor of dilation for everyone. So let's see v and v prime. What do you multiply to 5 to get 15? What do you multiply to 6 to get 18? You multiply 3, right? So for everyone, you should get the same factor of dilation. You should get the same scale factor. We can even go backwards in this one. Looking at the original figure that I gave you, notice that I multiplied the scale factor to every single vertice, right? And we created this new one. Let's say we were not given the scale factor and we were just given the two vertices. Again, we can just compare a to a prime. What I have to multiply to 2 to get 4? 2. What I have to multiply to 5 to get 10? 2. And so on. That is how you find the scale factor. Again, you might also be given just the shape. You can compare this side to this side, because this basically represents what I have here, a. So this will basically be a prime. So here you'll be comparing this vertice to that vertice, which of course are these two vertices. So you may not be given the vertices. You'll be given just the shape. But again, you can find the coordinate of each vertice and then compare them. Remember, they have to be corresponding vertices. A to A prime, C to C prime, and B to, this will be again, B prime. That's how you find your vertices. All right. Then I have like just a simple exercise. Then I have identify the figures that are dilated. Did the figure shrink or expand? So for the first two, that's my original figure. That's my dilated figure. Of course, this we can see that it's a dilation because the shape did not change. It only expand. My second one, I have this cross-looking thing, and then we have this kind of like bots, maybe. We can see that the shape changed. So clearly we can say that this is not a dilation. Number two, this is not a dilation because the shapes changed. I know that it shrinked, but we don't have the original, we could only have the same shape. So that means this is not a dilation. Again, then my hearts, I have this is a dilation. So this is a dilation. It shrinked. Alright, now let's go to the other page. We have dilate the following figure by a factor of 2. Check your answer by plotting each point. Be sure to label your figure. So dilate by a factor of 2. I already made an example of this on the first part of the video. You can check that again if you need help how to do that. I'm giving you your vertices. Plot the vertices of the original one, just to be sure that when you plot your vertices for the dilated figure, you get the same shape. Then we have here the setup of how I want you to input your answers. Again, I want to see A prime, B prime, C prime, and D prime. Then we have dilate the following figure by a factor of 3. I'm not giving you the original vertices. Notice these are the original because they don't have the prime thing. So you want to identify each of those vertices. Again, you can actually name these. If you want that to be your P, that can be your P. If you want that to be your Q, that can be your Q. If you want this to be your R, you choose. All right. Then I want to see your P prime, Q prime, R prime, S prime. Then we have, given the coordinate points of the original figure and the dilated figure, find the scale factor. Again, I already made an example on this video of how to identify the scale factor just given the vertices. Again, what do you multiply to get, and so on. And that's pretty much it. That's dilations. And remember, when we're given this, they might also ask us to find the area of the dilated figure or the perimeter of the dilated figure. The area and or perimeter, they don't just double. Well, I think perimeter does just double. Double check that and let me know if the perimeter actually doubles or if it doesn't. And that's pretty much for the video.